California codes, things that are happening on the other side of the country. This one's going to be a little bit different in that we're actually going to be able to see some products around the lighting space, and so it's a little bit of a shift in our focus, and then we'll finish up with the final presentation. So we're going to go a little bit later in the presentation because we started out a little late. So let me start out by introducing Sandra. I'm very happy to have her here. She has significant experience as an entrepreneur and co-founding many different companies in new industries. She's been president of Airphone, putting payphones on commercial airlines, CEO of In-Flight Phone International, where she built 10 companies globally. Instrumental in creating rail phone, putting phones on Amtrak trains. I mean, we probably use some of the products that Sandra's been instrumental in really bringing to market. She received a presidential appointment to the FCC Small Business Advisory Committee, where she was elected chair of the New Technology Subcommittee. That is significant. She's chairman of the Gokin Group Corporation, whose wholly owned subsidiary, Polybright, produced the earliest LED lighting products under the Borealis lighting brand for government, military, commercial, and industrial markets since 1995, making it the grandfather of LED lighting. Winning the 2012 Innovation Award for their A19 and lighting the Beijing Olympics were impressive accomplishments. She is the CEO and founder of Go Green LED Alternatives, registered with the CPUC, that's the California Public Utilities Commission, Utility Supplier Diversity Program Clearinghouse, as a majority woman-owned business. Go Green's an integrator dedicated to working with California businesses to provide energy-efficient LED lighting solutions, and has assembled some of the most innovative emerging technologies to integrate into LED lighting. She's addressed audiences worldwide on many, many topics, served as an adjunct professor at Southern Illinois University, and she is a graduate, or actually been inducted into the Hall of Fame, the Entrepreneur Hall of Fame at the University of Illinois at Chicago, and received an honorary Bachelor of Commercial Sciences degree from the University of St. Francis. So please, with all of these accomplishments and a great entrepreneurial background, I welcome Sandra to the podium for her presentation. Thank you.
Thank you. Now with all of those accomplishments, let's see if I can advance the computer.
So just use those keys right there.
Okay. Good morning, everyone.
Good morning.
It's very exciting to be here and talk about some of the things that I'm passionate about. I just have to first say that all of those accomplishments means that I'm very uneducated, and even though my father was a genius having started MCI, it's a well-known fact that genius generation skips, so I got none of the juice. But I got that entrepreneurial spirit, and that's what I'm going to share with you today. Now, looking out across the country, as an LED company, started 20 years ago, we look at, well, where's the low-hanging fruit? Where's the most amount of demand? California, with the closing down of San Onofre, their nuclear reactor, lost 20% of all of their generating capacity all at one time, overnight, for the whole southern region of the state. So you can imagine that was a pretty significant loss for them, and they were going to have to get really creative in what to do to make up for that. So the California Public Utilities Commission defines demand response as changes in electricity used by customers for their normal consumption pattern in response to changes in the price of electricity, the financial incentives due to reduce the consumption, changes in the wholesale market prices, or changes in grid conditions. The Energy Commission has come out with an integrated energy policy report saying that demand response can assist in the integrating of renewable energy to meet California's, at that point in time, 33% goal of going to renewables. Now in January, I don't know if anyone read this, I was quite shocked by this, in the Governor Jerry Brown inaugural address, he increased those goals to 50% renewables for the state of California. 50% by 2030. So you can imagine there's some very significant issues that the state is dealing with to accomplish those goals. In 2014, he included demand response in the Senate Bill 1414, directing the CPUC to establish new programs, do a lot of things that had never been required before, and to require the state to maintain the demand response and physical generating capacity adequate to meet all of these local requirements. So, interestingly enough, the CPUC in response to that mandated all of the IOUs, the investor-owned utility companies, to spend collectively $1 billion in 2015 on energy efficiency. One of the senators, Lois Wolk, said in demand to the Senate bill that demand response programs will not only enable Californians to get rebates in exchange for reducing their electricity use during these peak times, but that this will reduce the need for costly and polluting power plants that run only when there is a peak demand for electricity. And until I read that, I really didn't think about just how important that really is. So the benefits of demand response, and this is going back a few years, this is 2009, but we're looking at what was shaved off and eliminated by using demand response. You're looking at about 2.2 megawatts, and the hours of this are interesting because the hours are really kind of like 3 to 5, 3 to 6, and so it's a little bit later back then that we're looking at. I want you to remember that because we're going to come back to that in a little while. The California ISO has created this demand response and energy efficiency roadmap, and that lays out how all the different government agencies have to work together to make this possible, especially the Energy Commission and the CPUC. So with these mandates that have happened, the IOUs had to come up with some pretty innovative programming. Southern California Edison, they had to add 1,400 to 1,800 megawatts of grid capacity in their region by 2020. This local capacity requirement request for offer, as we affectionately refer to it as the LCR RFO, included the first ever mandate to include at least 50 megawatts of energy storage and at least 650 megawatts of preferred resources. Now keep in mind, preferred resources are your renewable power, energy storage, efficiency, or demand response. And so I can tell you, they put out a tender, and I responded. Unfortunately, I didn't win, but I learned so much because what they were doing was inviting innovators all over the country to come into their region with their own solutions. They didn't tell us what we had a tender. We could come up with anything from changing set points for swimming pools to, in my case, I bid LED energy efficiency programs, and it was a dollar amount that you were bidding per megawatt that you were going to guarantee. And you weren't getting paid anything until after your programs were installed, operated, and then verified over a 5-year period so that they could prove to the CPUC that everything was as promised and energy efficient. In addition to that, they also offered incentive payments of up to $300 per kilowatt of verified load reduction, up to 100% of the project cost, and they would do 60% right after you could prove that everything was done and installed properly, and then 40% 12 months after. You had to commit to a DR for 3 years to qualify for that. Pacific Gas and Electric, they did the same type of a program at $200 per dispatchable kilowatts, the same kind of commitments. Now the Demand Response and Smart Grid Coalition, they say, this is shocking to me, that 100 hours of peak demand usage nationwide accounts for 10 to 20% of the nation's cost of electricity every year. Now that's staggering. If people would realize that, they would wake up and say, we've got to get on the bandwagon and really come up with ways to do this. Now remember the 2009 grid we were talking about, that peak demand hour? In California, they're all talking about this duck curve, which is the demand response, not at the typical time everyone's used to seeing. It's happening at 8:30 at night. What is causing such a shift? Well, this is so unusual. At 5 o'clock, all your renewables are done. Solar's over, wind over, this big sharp drop off in all the energy that the grid's been counting on all day. Right at the exact same time, everybody's coming home and they're plugging in their electric cars. An electric car is consuming as much power as the entire house, just to put it in the right context. And then, you know, we're all coming home, we're plugging in every known to mankind electronic device, charging our phones and our iPads and our battery packs for everything. So all of this huge amount of demand is really forcing this enormous peak that is all hitting the grid at the same time. So grid stability is really important. And think about the backwash that happens when that much power is lost from the generation of renewables at the same time the demand going up. So you've got to level that load. You've got to come up with innovative ways to take care of that. Now, the design, construction, and placement of a building, of course, plays a heavy role in your energy consumption. And for pre-existing buildings, you don't have that choice. They're already there. They may have been designed smart or not. And so you have to come up with things to existing infrastructure, really key to be able to take advantage of that. And so these are the factors that can be managed by the use of innovative new technologies and integration tools with demand response. Lighting, believe it or not, is the #1 electricity load, not HVAC, and it's still 97% uncontrolled. Lighting, it's either on or off. As we know it today, it's just mostly on, wasting energy, whether people are in the room or not. So that's a huge drain on the system, needlessly. The challenge is in reducing the electrical consumption while absorbing the excess power for later use. Usually with renewables, with solar and wind, you're either use it or lose it. When you got it, if you're using it, it's great, but most of the time if you're not using it, it's just gone. There really hasn't been that ability to store it. So along comes life-changing Title 24 requirements. Now this was my worst day of my life and turned out to be my best day of my life, and I'll share with you why. I was in with the Energy Commission, talking to the commissioners, all excited. I was showing them things that would just rock their world that we were going to do in California with LED lighting. And they looked at me and said, we've just banned that technology. You can't bring that into our state. I'm like, what? I thought they were kidding. They said, no, Title 24 building codes are going to eliminate the use of LED tubes. That's a fluorescent tube that you could replace and put an LED tube for half the power. I said, why in the world would you do that? They said, because the California Lighting Technology Center showed us that they just don't give us the good lighting distribution that we would like from fluorescent tubes. They spread the light, there's even distribution, they throw the light on the walls, it's vertical and horizontal. Everybody's used to light like that, but these LED tubes, they're cheating. They're showing bright light coming straight down. Remember, an LED is very directional, and it's not spreading the light. So there's these shadows of dark. And I'm showing mine going, no, 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 you don't understand. This is really good. This is great light distribution. And they're like, yes, it is. It's incredible. We're very impressed. But it's about 5 years too late. I'm like, what? They said 5 years ago when we went to rulemaking, you weren't even on the market with that. You didn't show us that. The tubes we saw were cheap, bad things coming out of China that didn't throw the light, that didn't look good. So we wrote legislation that said, you're not going to bring that into our state. So Title 24, that was enacted July of last year, calls for some very serious consequences. They did, in fact, outlaw the LED tube as we know it today. What they also required was the addition of daylight harvesting, dimming controls, and motion sensing on any facility that installed more than 40 light bulbs. Now think about the cost in doing that. sensors, controls being mandatory required by building codes. Now, the bad news for me was, oh my gosh, all these years of work and all these massive amounts of schools and everybody ready to finally go and retrofit their tubes with LED tubes and jump their ballast and put this in the same space and go to the dead end, and this was kind of like a, a fake end. All of that was gone. And so come July, life was horrible. I just couldn't see, I was out the window, I was just ready to jump. But this is what's so cool about a need like this coming on the marketplace. It forces change. It forces a change in the way that you think, the way that you create product, the innovation that you have to adapt. So what I respect so much about the Energy Commission for having the guts to make a gutsy rule like that is it made a lot of us vendors go back to the drawing board and come up with new and innovative solutions, products that would meet those codes. So, in that code, the biggest problem is, and you will understand this, most of the school buildings were built before 1980, weren't they? And so they have asbestos issues. And most government buildings were built before 1980. They have asbestos issues. Asbestos remediation costs $1 million minimum. So when you start putting controls in, drilling holes, pulling wires, that gets to be very expensive. Sometimes a showstopper. And so all of this is the backdrop from where we're now moving forward through this. That's when I got busy with Go Green, my little woman-owned business, to pull together the types of technologies that for the first time were required to integrate. Because up until that law came, that building code changed, everybody was in silos. You were a lighting company, or you were a control company, or you provided demand response, or you were the security company, or you were the maintenance, installers, but no one had to do anything together. So now, for the first time, you're able to meet those codes, which, by the way, require demand response on all new construction. So any building that was going up, that was going to have lighting, had to be able to be demand responsive, or it wasn't going to get its Title 24 compliant stamp. So now, all of these embedded sensors, all of this integration becomes really key, very, very important, so that control of your building loads can be reduced. You can take out lighting from unoccupied spaces. You can reduce the heating and air conditioning in low usage rooms. Light sensors are dimming everything down so that it's the right light levels. And all of this can be done pain-free. No one is asked to suffer. That is the beauty of what we're talking about. Now, in a school environment, this is interesting, they say that the concentration is better if you have equal amounts of light horizontally as vertically. So that if you're in a poorly lit room and there's no vertical light on the walls, it requires more concentration for a student to learn. Color temperature affects how they learn. You can actually get HDDV kids off of the drugs if you have the right color temperature given what you're teaching. Linguistics and things like that might be better at 3,000 Kelvin temperature. Math and science might be better at 5,000. With LED lights, you can actually change school temperature, color temperature. So we were doing studies and looking at what was the lighting looking like, what was the levels of light, how were vertical light distribution. Remember, fluorescent has 60% of the color replication, where LED will be over 86. So the colors of clothes will pop, skin tones, everything looks better. When I was shooting, this is a school district we did, you can see the before after it was with fluorescent. I had to prove that LED tubes did have light distribution, and oddly enough, what I found was a blackboard truly is not black. It turned green. With good quality lighting, the blackboard turned green, and colors popped, and walls were vivid, and the vertical light distribution up on the walls was equally as bright as what was horizontal. So for school lighting, it was like, wow, that's cool. Now what are the economics? When you do a really smart retrofit for a school district, and this is 60 million square feet, you can save $1.1 billion. You're looking at return on investments as short as 6 months. When you look at corporate headquarters, for those of you that have buildings, you're looking at T8 replacements with LED products that can save $8.8 million just changing out 18,418 existing tubes. With controls, this is an interesting study that we found. With controls, they had one floor that went to all the latest and the greatest and one floor that was your control floor. They found that individual workstations where they had their own control of their light were 42% savings than just having the ambient light that they set the levels for. And that occupancy sensors saved an average of 35%. In daylight harvesting, the ability to turn down when you've got daylight coming in, dimming and everything, keeping it consistent to 50-foot candles on the surface, that saved 20%. The interesting thing that came out of this study was 40% light reduction actually was preferred by all of the employees. And so it confirms what we suspected, that we overlight most of the facilities to start with. So now enters intelligent wireless control systems integrated with lighting. And when I talk about integrated, I mean totally integrated. This is where an entire building becomes an entirely intelligent building, and everything is working together. All different types of lighting are leveling their loads, they're moving back and forth. The sensing, if there's nobody in the room, those lights are off. If somebody's in one part of the room, the other part of the room dims down. All of this is with controllers that are all coming in with a cloud-based software analytic system to give you the total control over it, the ability to shed load right away with demand response, and it's because it's fast acting that it's so important for demand response. So you're talking about getting down to not only the day of response, but within 10 minutes. In a pain-free environment where you're not asking anybody to get hot, you're not asking anyone to go through feeling braille, how to get through the building. This is pain-free. Really makes sense. And this is what rocked my world, and I'm sharing it with you because it's phenomenal. There is a little-known study in the Resler Polytechnic Institute that shows the human iris adjusts over 7 minutes of time to not be able to perceive any difference in brightness. So that means if your dimming is timed from 7 minutes from start to finish, you can take 20% of your entire light load off and no one even noticed. Now that is a significant fact. No pain, and yet 20% savings, and no one even noticed. There's another study that's really interesting, and this SMUD did. That's a Sacramento Municipal Utility District. They were starting out with dimming the lights, all these different increments, and then running their controls to see what they could really do. They were able to reduce their lighting load by 32%. Their economic benefit was 49%. Their average was 33% savings with controls, and they prove up that most people prefer lower light levels. Now, one of the things that I want to share with you on that building code, which is something that's really exciting, is an LED tube can just go right up into the existing socket if you keep the ballast there, and it doesn't trigger code. And this is something that no one knows about. The state of Illinois started to do this, and nobody else knows about it other than California that I'm aware of. When they outlawed the tube, they did that in kind of a clever way. They said, well, the tube can be there, but it can't have pins on it, and it can't have the ballast there, and you have to gut everything there. Well, there's nothing to stick the tube into when you do that. That's the de facto law that says they outlawed it. So, to be fair, and to really come up with I don't want to call it a workaround or a Band-Aid, but that's in effect what it is they said, okay, we'll look the other way. If the tube stays in the exact same thing and nothing else changes, then we're safe. We'll let you do that because you can't go backwards. What they didn't really want to do is have a fluorescent tube come down, the ballast removed, the LED tube go in, and then somebody changes it in maintenance and they put in a fluorescent tube and there's no ballast to protect the energy surge. So by using what we call plug and play, it's a tube that goes into the same spot and it just saves 50% of the energy. So this is one choice for saving energy. The design kit that we had to make to work around what they really wanted, the Title 24 compliant retrofit kit, is we did invent the tubes. We made them without the little bipins in the end. And we put them on a pre-existing plate. And then the driver and all the controls and the wireless was added right into 2, 3, or 4 tubes mounted on a plate that would press right up inside an existing dropper. Pretty clever lighting design to meet that requirement. The interesting thing about tubes, which I just love, is tubes used to have a lot of technology inside them. They used to have this many inches of components. So now that was already heavy and costly and a little bit of heat in each one of those components. Nowadays, the way we make them, there are no components, there's a chip. One tiny little chip. And that one little chip is what we integrate the wireless capability to that allows it to do everything you need it to do to be compliant. So look at that. It looks just like a fluorescent tube. There's no hot spots. There's no shadowing. It's a great light distribution, great throw, and totally without any electronics except a chip in the end cap. Therefore, there is no weight. No weight, it can go anywhere, but it can have intelligence in it. Wireless communications. That is very exciting, how that opens up the door. The other thing is you can take down everything and gut your fixture and not touch anything else, and you can lay in strips. There's strips of LED in here. You can lay in a grid of strips and then put your cover right back over it. And so that becomes a retrofit kit, very inexpensive, just showing you on the back. You lift up your little pack of electronics and sits on the back side of that. That's your retrofit kit that gives it all the wireless. But here's the dirty little secret. This is a printed study of an Intel facility by the Sacramento Municipality, SMUD, the utility company, that says the normal so-called wireless systems have a 9.7-year return on investment. That's a showstopper for most companies. I'm sure it is for schools. And the reason is because it truly, what they call wireless, isn't really wireless. It's half wired, and it's half wired, hardwired and wireless. And so where every 20, 30 fixtures might be wireless come into a little pack, all those little controller packs, you see the green line going down the back? Those are all holes drilled in the floors and the walls down to the head end. When you drill through, now you're to the asbestos remediation issue, you're into the high cost of installation, that would be probably one of the more normal installations that would occur in the typical way of doing lighting controls that are laying on top of anybody else's lighting. So that's the bad side of what they want. Here's the exciting thing that we've been forced to do in Pioneer is complete total integration where you don't have any hard wires comes from having controls that speak to the lighting. That's why I wanted to show you the chip that's inside. This is a complete wireless peel and stick. You reach up as high as you can, slap that on your wall, and the first part is a little photovoltaic charging unit. The middle one is your motion sensor, so if everyone was still for 5 minutes, it would turn the lights off. And in daylight harvesting is measuring foot candles to make sure it's 50-foot candles. If the light comes in, it's going to dim everything down. The light goes away, it's going to bring everything up brighter. And so wireless controls like this that can have gunshot protection, they can test the air to know how many people are in here and report back and say, why waste air conditioning like you're doing? Then the next thing, remember that dimming that was required? Nobody has dimmers in the schools because they had fluorescent tubes that didn't typically dim. Now to go change just a simple light switch to give you the required dimming, this is a wireless switch that turns things on and off. There's no batteries in this. There's no plug-in to electricity. How does it do that? It operates on piezoelectricity where you're creating the energy from pressure. When you hit that switch, you're creating just enough energy to turn on and turn off and dim down the products. And so that really saves you labor and all the different things. And then putting battery storage right into the light. My favorite light that we make, I screw into my ear and then turn it on and everyone's like, wow! And they believe me that they're really battery storage is just all it is, it's an AC/DC battery storage. And so you do the same thing with street lights. Everything we're talking about indoor lighting can go into your outdoor lighting, your street lights. What does that do? Gives you way, way, way brighter, better quality light, more consistent. We put a battery inside the street light, and now you've got demand response with an entire distributed network. You can get, out of every 100,000 roughly streetlights, you can save 5.4 megawatts. That's significant. That's a lot of power to take off of a city, off the grid, with absolutely seconds of response time, and nobody knows it. You'll dim it down 50%, but nobody's going to even notice that they're on. Now, crime has been proven to be decreased 21% when you do go to LED lighting because people can't shoot it out. So you're always going to have a really good light distribution with LED. You're going to have a lot brighter. You're going to have better color temperature, better replication. Think about outdoor for parking lot, dimming, all the intelligence. Why light up a parking lot when there's nobody out there? Make it get bright when people are out there and move. And think about battery storage. What a great way to augment everything that you're doing by taking any of your renewables and putting battery storage in there so that you've got a tank, like a tank that would be next to the building. It's just holding your power and then you're using it instead of banging right onto the grid. So you can do anything from 1 kilowatt to 1 megawatt installed, and just backs up and helps even everything out for the grid. One of the things that's important is everything is software driven. It's all off in a cloud. It's on a computer. You don't have to have a front end. You can put 100% wireless on every floor and have one guy with his computer program checking it and controlling it, or 5 guys, or call somebody to make changes. It's really easy all over the air. One point I want to make is true cybersecurity, the requirement for having everything be safe. You don't want to have them get hacked into it. There's 3 federal mandates that I found. Clinton signed it into law, George Bush signed it into law, and so did Barack Obama. So what that means